In this video, we're going to activate the Windows 10 built-in Open SSH feature, use Windows 10 built-in SSH commands, explain why you should get comfortable with GitHub, generate SSH keys to secure the GitHub online service, and create a repository on GitHub and clone it to a local machine. The secure shell or SSH is an authentication mechanism where a private local key is paired with a public remote key. It can be used to secure online services such as GitHub. The built-in SSH client is enabled by default in Windows 10 April 2018 update. It is an optional feature that needs to be installed. In your Windows 10 computer, type settings in the search box in the bottom left corner. Click on Apps, and this will take you into Apps and Features. Select Optional Features and click on Open SSH Client. Mine is already installed, but installation is pretty straightforward. PowerShell comes bundled with Windows 10, but you can find it by searching in the same search box, but mine is pinned to the taskbar. We will need to run it with administrator privileges. Type get-windows capability --online pipe symbol --name like open quotes open SSH * close quotes and hit enter. If the Open SSH client is installed, this will be indicated by the state parameter. So if it was already installed, you could have skipped this step. You can also install the Open SSH client through the PowerShell by typing this command: add-windows capability --online name OpenSSH.client. It wouldn't be necessary for me to do a restart because the client is already installed on my machine. Once everything has been set up, run ssh-keygen. This will generate a public-private RSA key pair. If you hit enter, the keys will be saved with a default name in the home folder. You will need to enter a passphrase for this key. You will have to verify it by entering it again. It tells you where the RSA key pair is stored. It gives you the key fingerprint and the key's random art image. If you go to the location specified, you should be able to see the folder that contains the key pair. The dot prefix indicates that this folder is hidden, and you will need to enable Show Hidden Files and Folders in the folder options. Open the file that is 1 kilobyte. This will be the smaller one. It contains the public RSA key. You can open this file with Notepad. Notepad comes bundled with Windows 10. The public RSA key has a prefix of SSH-RSA. We will need to copy the key to help us set up our GitHub account. GitHub is a web-based platform used for version control. It makes it easy for other programmers to collaborate on projects. The projects that we built in this course will be uploaded to GitHub. You will need to create an account on GitHub. It's free. Log into GitHub, click the drop-down next to your icon in the upper right corner and select Settings. Select SSH and GPG keys from the menu. We want to enter the SSH key that we created. Click New SSH Key. Give your SSH key a name. Mine is named after the computer's name because it is the machine that I work on. Copy and paste the SSH key into the box that you created earlier. Click Add SSH key when finished. This will require you to re-enter your password. The SSH keys associated with your account are stored in this section. Go to your repositories page and click on New. Give your repository a name. Since we are building a dictionary API, this repo will be named English Dictionary REST API. A description is optional. You can set the repo to be public or private. It's also a good habit to initialize the repo with a README. Add a gitignore file. The language will be Python. Add an MIT license and click Create Repository when done. In this video, we're going to set up SSH on Mac, explain why you should get comfortable with GitHub, generate SSH keys to secure the GitHub online service, and create a repository on GitHub and clone it to a local machine. The secure shell or SSH is an authentication mechanism where a private local key is paired with a public remote key. It can be used to secure online services such as GitHub. With a window open, hit Command-Shift and H to go to the home folder. To see the hidden files, hit Command-Shift and period. To hide those files again, you can hit Command-Shift and period. There's a hidden SSH file in my home folder. I'm going to delete this file so that you can follow along with me. If you already have this file, you probably have your SSH keys set up already. Alternatively, you can open a terminal window and type ls:/.ssh. If you don't have SSH set up, you will see no such file or directory. Type ssh-keygen -t -rsa -b -4096 -c followed by your email address. This will generate a public-private RSS key pair. Hit Enter to save the file in the default location with the default file name. You will need to enter a passphrase for this key. You will have to verify it by entering it again. It tells you where this RSA key pair is stored. It gives you the key fingerprint and the key's random art image. I am going to check to see if the file is in the folder specified by typing ls:/.ssh. Two files are listed. The file with the .pub suffix is the public key. Type cat:/.ssh/id_rsa.pub. This will output the contents of the public RSA key to the screen. The public RSA key has a prefix of SSH-RSA. We need to copy the key to help us set up our GitHub account. GitHub is a web-based platform used for version control. It makes it easy for other programmers to collaborate on projects. The projects that we built in this course will be uploaded to GitHub. You will need to create an account on GitHub. It's free. Log into GitHub, click the drop-down next to your icon in the upper right corner and select Settings. Select SSH and GPG keys from the menu. We want to enter the SSH key that we created. Click New SSH key. Give your SSH key a name. Mine is named after the computer's name because it is the machine that I work on. Copy and paste the SSH key into the box that you created earlier. Click Add SSH key when finished. This will require you to re-enter your password. The SSH keys associated with your account are stored in this section. Go to your repositories page and click on New. Give your repository a name. Since we are building a dictionary API, this repo will be named English Dictionary REST API. A description is optional. You can set the repo to be public or private. It's also a good habit to initialize the repo with a README. Add a gitignore file. The language will be Python. Add an MIT license and click Create Repository when done. In this video, we are going to explain what Git is, install Git on Windows, configure Git, and list common Git commands. Git is a free open source distributed version control system. It is used to track changes in source code during software development, and it allows you to have multiple local branches that can be entirely independent of each other. Git can work with GitHub, but both can be installed independently. Remember that GitHub is a service and there are other version control services such as GitLab, Bitbucket, SourceForge, or Launchpad. These are some common Git commands that will be used in the course. These commands will be explained in more detail when they're being used. Go to this website, git-scm.com/download. Click on the Windows link and this should start to download the installer. Open the installer when it's finished downloading. Install Git with all the default settings. When the installation is complete, it will take you to the release notes page. Open PowerShell or command prompt and run git --version to see which version of Git is installed on your machine. Depending on when you purchase this course, your version number may be different. There is just one last thing that we need to do. We need to add a username to our Git repositories. We can do that by running git -config --global user.name and pass in a username. Hit enter when done. Type this command followed by an email address to add an email to our Git repositories. Hit enter when finished. In this video, we're going to explain what Git is, install Git on Mac via Homebrew, configure Git, and list common Git commands. Git is a free open source distributed version control system. It is used to track changes in source code during software development, and it allows you to have multiple local branches that can be entirely independent of each other. Git can work with GitHub, but both can be installed independently. Remember that GitHub is a service and there are other version control services such as GitLab, Bitbucket, SourceForge, or Launchpad. These are some common Git commands that will be used in the course. These commands will be explained in more detail when they're being used. Go to this website, git-scm.com/download/Mac. If you already have Xcode installed, you can skip this step. Homebrew is a package manager that can be used to install Git and other packages. Go to the Homebrew website by clicking on the link. This takes us to brew.sh. To install Homebrew, copy the command that is there and paste it in the terminal and hit enter. This will prompt you for a password. Enter the password for your computer. The installation process should take a couple of minutes. Type brew --version. This command will tell you the version of Homebrew you have installed. Now that brew is installed, we can use it to install Git. Copy and paste brew install Git in the terminal and hit enter. Homebrew takes a couple of minutes to install. Run git --version to see which version of Git is installed on your machine. Depending on when you purchase this course, your version number may be different. There is just one last thing that we need to do. We need to add a username to our Git repositories. We can do that by running git --config --global user.name and pass in a username. Hit enter when done. Type this command followed by an email address to add an email to our Git repositories. Hit enter when finished. In this video, we're going to clone the project to your computer, and then we're going to open the project with the editor. Open PowerShell or Command Prompt in Windows or Terminal on Mac. Navigate to the location where you want to store your project. Remember that on Windows you use backslashes and on Mac you use /. Open the project repository and click the green button that says Clone or Download. We have the option to use HTTPS or SSH. For now, we are going to use HTTPS. Click the clipboard icon to copy the link. Return to PowerShell and type git clone and paste the link. The command should be the same using the command prompt and terminal in Mac. Hit enter when done. You should now be able to see the project folder at the location you specified. Open PyCharm and drag the folder into our project. On Windows 10, PyCharm is going to complain and say that Windows Defender might be impacting your build performance. Click Fix and select Configure automatically. This will update the Windows Defender configuration. In this video, we're going to create a new branch on GitHub, set up the virtual environment, and use the virtual environment to install Django, the Django Rest Framework, and Markdown. Each video in this tutorial series will have its own branch on GitHub. This makes following along so much easier. To create a new branch, type git checkout -b followed by the name of your branch. Once the branch is created, we'll edit the files. Once the files are edited, type git add followed by a space and a period. Add a commit message by typing git commit -am followed by a commit message. Then push the branch to the remote repository by typing git push -u origin followed by the name of your branch. Open the built-in terminal and type git checkout -b, setting up the virtual environment. Be sure to include the correct spaces and underscores. The terminal should return a message indicating that you have switched to a new branch followed by the name of the branch. To create the virtual environment, type python -m-venv -env. On Mac, you need to type python 3 -m-venv -env. On Mac, Python 2.7 was installed by default. We then installed Python 3 and in order to use Python 3, we have to specify Python 3. On Windows, there were no versions of Python pre-installed, so we installed Python 3 and we do not need to specify. To activate the virtual environment on Windows, type env /scripts/activate. This is the location of the activate.bat file. To activate the virtual environment on Mac, type source /bin/activate. If you have done everything correctly, you should see the name of your virtual environment in parentheses. The next step is optional but highly recommended. Open the File menu of PyCharm and select Settings on Windows or Preferences on Mac. Click on Project and select Project Interpreter. Since no Project Interpreter is selected, click the cogwheel and select Add. Make sure that your settings match my settings, but the location of the interpreter may be different. We want to use the interpreter that was created with our virtual environment. Click OK and you should be able to see the packages that were installed. Click Apply and then click OK. Now that our virtual environment is set up, we can start installing our packages. Because we are using a virtual environment, these packages will be isolated from the rest of our computer. To install Django, type pip install Django. The process will take about a few minutes. To install the Django Rest Framework, type pip install Django Rest Framework. This takes less than a minute to install. Finally, install Markdown by typing pip install Markdown. This process doesn't take long. Opening the project settings will show you all the packages that were installed. We want to add these changes to the GitHub repository. Type git add space period. This command tells Git that you want to include updates to a certain file or files in the next commit. Type git commit -am followed by a commit message in double quotes. Hit enter when done. This will show you all the changes you have made. Type git push -u origin followed by the name of the branch that you created. Hit enter when done. If you visit the GitHub page, you should be able to see the branch that we just created. Later in the course, I will show you how to clone a branch to the local machine. In this video, we're going to create the project and discuss how projects in Django are structured. Currently, we have our virtual environment. This contains our Django Rest Framework, and Markdown packages. We also have a git ignore file as well as the MIT license and a README file. When we create our Django project, we are going to get a folder containing init.py, asgi.py, wsgi.py, settings.py, and urls.py. These are called modules. In this course, we will be focusing on the settings and URLs modules. Manage.py is created in each Django project. It is a command line utility that lets you interact with a Django project. The API that we are creating is going to be an app. A Django project may be made up of multiple apps. Each app will have its own migrations folder, admin, apps, models, tests, and views modules, and an init.py file to indicate that it is a package. Don't worry about the templates, media, or static folders at this point. We're going to be focusing on building the API. Open the terminal window and type Django admin start project English dictionary followed by a space and a period. Be sure to include the necessary spaces, hyphens, and underscores. The period at the end will add the project to the current folder. Hit enter when done. Type python manage.py start app English API. Include the necessary spaces, periods, and underscores. Hit enter when done. If you examine the folder structure, you should be able to see the files that were added. Open settings.py and go to the list of installed apps. We first need to add REST Framework. Place REST_framework between quotation marks. Add a comma because we need to add the app that we just created. All of the apps that we create will have to be placed in this section. Add the name of the app that we just created in quotation marks. The name of the app should correspond to the name of the app folder. In this video, we're going to create the model to represent the data we want to store in the database, create the database tables, register the model, create a super user, and push the branch to GitHub. When you're building a model, the first question you need to ask yourself is what type of data do we want to model? In a dictionary, for each word, there are meanings of each word and examples of the word used in a sentence. Open models.py in the app folder. Create a class named word which will inherit from models.model. Create a field for the title which will be char field. Set the maximum length to 255 and set unique to true. Create a field for the meanings and set it to models.text field. Create a field for the examples and set it to text field as well. We'll next create a function that returns a human-readable name for an object in the database. So rather than using some code, we'll set the function to name the object using its title. In the terminal, type python manage.py make migrations followed by the name of the app. We don't need to include the app name, but it is best practice when working with a project that contains multiple apps. This command will generate the SQL commands that are used to generate the database tables. Run python manage.py migrate to execute those commands and generate your database table. We next need to create a super user, and we can create super users using python manage.py create super user. We need to provide a name. If you want, you can leave it blank and use the default name. We also need to provide an email address. Add a password. You can use a simple password and also bypass password validation. Run python manage.py run server, and this command will start the development server at 127.0.0.1:8000. To log into the admin console, go to this address in your browser and use the credentials that you created for the super user. We can't see the model because we haven't registered it in the admin module as yet. Return to the editor and open admin.py from the app folder. Import the model by typing from .models import word. The dot placed before model indicates that the admin and the model modules are in the same folders. To register the model, type admin.site.register and pass in the model name as an argument. If you refresh the page, you should be able to see the model. Click Add to add a word to our database. When you're finished adding the word, click Save. To see the meaning of the word or make any changes, just click on the word. Return to the terminal in the editor and let's save our changes and create a new branch. Type git checkout -b, creating the model. Include all spaces and underscores and hit enter. This will switch you to a new branch. Type git add space period and hit enter. Type git commit -am followed by a commit message in double quotes. We created the project and built the model. Hit enter when done. If you log into GitHub, you should be able to clone this particular branch of the project. In this video, we're going to explain what a serializer is, create a serializer, and push a new branch to GitHub. Serializers allow complex data, such as query sets and model instances, to be converted to native Python data types that can then be easily rendered into JSON, XML, or other content types. They also provide deserialization. In deserialization, we convert the parse data, which may be expressed as JSON or XML, back into the complex data types after incoming data has been validated. The model serializer class closely maps to Django model definitions. You can create a serializer class with fields that correspond to the model fields. Model serializers will automatically generate a set of fields for you based on the model. They will also generate validators for the serializer, such as unique together validators. A model serializer includes simple implementations of .create and .update methods. Create a new Python file and name it Serializers in your app folder. Import Serializers from the REST framework. Import the model from the models module. Create a class and name it Word Serializer, and this will inherit from serializers.modelSerializer. You may add a docstring to indicate what this class is going to do. This class is going to serialize the Word object. Create a meta class and add a model attribute. Set it to the name of the class that we want to serialize. Add an attribute named fields and set it to a string containing all _, and this will expose all the fields in the model. Type git checkout -b, creating a serializer, including all spaces and underscores, to create a new branch for our project. Hit enter when done. Type git add space period and then hit enter. Add a commit message. Finally, let's push the changes we made to our branch. When we go to GitHub, we can select the branch that we want. Select creating a serializer. If we open the app folder and select serializers.py, we can see all the changes that we have made. In this section, we're going to define API views, explain when to use API views, and use a GET request to fetch objects from the API. The Django Rest Framework provides an API view class, which subclasses Django view classes. The API view has its own response and request instances and doesn't use Django's HTTP response or HTTP request. API views are the most basic and customizable. They have methods that mirror the standard HTTP methods such as get, post, put, patch, and delete. Use API views when working with local files or data, calling other APIs, or implementing complex logic. Open views.py from the app folder. We need to import API view from REST framework.views. Import response from REST framework.response. We import this class because we want to use a nicer interface for returning content negotiated web API responses that can be rendered in multiple formats. Import the model and import the serializer. On line 4, there should be a space between from and .models, but in this case, the IDE understands what I meant to type. Create a class and name it wordlist, which will inherit API view. Add a docstring to describe what this class is going to do. We want this class to list all of the words in the database. Create a function named get, which has two parameters. Self, because we are creating a function in a class, and this keyword gives us access to the attributes, and methods and requests, because the user will have to request the data. We can access all the word instances by using word.objects.all and storing it in a variable named words. We next need to serialize the word instances by passing the list of words into the serializer that we created. Set many to true, which tells the serializer that you want to serialize multiple items. The .data attribute is the unrendered serialized data of the response. We can store all of this in a variable named data. We return the response and pass in the data. Create a urls.py in the app folder. Don't confuse this with the main urls.py file. Import path from Django URLs and import the wordlist class from views. URL patterns is where you would define the URLs you want to use for your API. This is how we would go about defining the first URL pattern using the path function. It takes 3 arguments. The last one is optional. We need a string and a function for the first 2 respectively. Open the main urls.py, which is in the root of the project folder. We need to import the include function from django.urls. We have to use the path function again, and we need a string as the first argument. It can be left as an empty string, but I'm going to use v1/API/ because this is version 1 of my API. The next argument is going to tell Django which folder to include so that it can find the URL patterns for our API. Open the terminal and start the server. Go to 127.0.0.1:v1/API/words in your browser. We should now be able to see our API. There's only one word in our API, and currently there is no other way to add words unless we go through the Django admin console. In the next section, I'm going to show you how to add words to this API using post. In this section, we're going to define a post method and use this post method to add new objects to the API. Under the get method that we created in the last section, we're going to define a new method named post, which is going to take self and a request. We will create a variable for the serializer just as before, but we will serialize the user's request data. Serializer.isValid raise exception equals true will automatically raise an exception if the serialized data is not valid. Once the serialized data is valid, we will want to save it. Import status from the REST framework. Finally, we want to return a response which contains the serialized data as well as an HTTP status code. Since we are creating an instance, we want to return a 201 status. Restart the server by typing the command in the terminal if it has stopped running. Make sure that you type the correct URL in the browser or you will get a page not found error. If you have done everything correctly, your API should look like this. Currently, we can get items from the API, and we can also post items to the API in the section that says content. However, when we are posting items, they have to be in JSON format. Posting in JSON format is likely to introduce errors. I'll copy and paste the first entry and change the ID as well as the title, meanings, and examples. The word that I want to use is coder. A coder is a person who writes code for computer programs, and for the example we can type, "This man is an excellent coder." If I accidentally forget to add a comma or a quotation mark, I could run into an error. If the page is refreshed, we should be able to see the entry that was just created. However, we have a serious issue that needs to be addressed. Logging into a private window shows that users who are not authenticated have access to the API and they can read and write to the database. We will tackle this problem in the next section. In this section, we're going to set a default authentication class, set a default permission class, set the pagination style, and push changes to a new branch. The default authentication schemes can be set globally in the Settings module by adding a setting for default authentication classes. These settings include Basic Authentication, Token Authentication, Session Authentication, Remote User Authentication, and Custom Authentication. In this section, we will be using Session Authentication. This allows you to authenticate users similar to the way Django authenticates users without the Django Rest Framework. This means that you need to log into the Django admin before you can post to the API. The pagination style will allow you to modify how large result sets are split into individual pages of data. The page number pagination class includes a number of attributes that may be overridden to modify the pagination style. Page size is a numeric value indicating the page size. Open settings.py and scroll to the bottom of the file. Add a comment for REST framework. We need to create a dictionary for the REST framework settings. We need to set the default authentication class. Set this to REST Framework Authentication Session Authentication. Include the necessary underscores and periods. Default authentication classes expects a tuple of values. So our value, even though it's a single value, must be placed in parentheses and we need to include a comma. The default permission classes also expects another tuple. We're going to set the permission to REST Framework permissions is authenticated or read only. Include the necessary underscores and periods. We'll next set the default pagination class. Set this to REST Framework.pagination.pageNumber pagination. Include the necessary underscores and periods. Finally, we want to set the page size to 10. This default pagination class will come in handy when we are looking at generic views and viewsets. Currently, I am not authenticated, and when I run the server, I have lost the ability to post to the API. I will need to log into the Django admin interface. When we return to the API, we should have the ability to post. Let's push our changes to a new branch. Type git checkout -b adding permissions, including all spaces and underscores, to create a new branch for our project. Hit enter when done. Type git add space period and then hit enter. Add a commit message and hit enter. Finally, let's push the changes we made to our branch. Remember that you can view all of these branches on GitHub. For some reason, if your code may not be working as expected, you can clone the specific branch that you need. In this section, we're going to discuss advantages of using generic views over API views, use generic views with our API, and add, delete, and update words to the API using generic views. Using generic views allows us to achieve the same result with less code. API views would require us to create a class to handle an individual item. For example, we would need to create a word detail class, and we would need to define methods for get, post, delete, partial update, and update. With generic views, you can quickly build an API that maps closely to your database model. The generic view classes are built by combining generic API view with one or more mixing classes. Rather than delete the code contained in views.py, let's rename this file to be API_views. When we do a refactor, the IDE is going to look for references of views.py and rename them to APIViews.py. Select the app folder and create a new file named generic_views.py. Import generics from the REST framework. Import models. Import serializers. Create a class named listCreateWords, which will inherit from generics.listCreateAPIView. We need to add an attribute for query set and set it to model.word.objects.all. The query set is just a collection of objects from the database. We also need to add an attribute for the serializer class and set it to serializers.wordSerializer. This is the serializer that we created earlier. We will serialize the objects from the database. This is all the code that we need to list the objects from the database. Open urls.py in the app folder. Add a comment to line 2 because we are not using API views, but we now have to add an import statement so that we can use generic views. Add a comment to line 6 because word list is defined in API_views.py. Create a new path which takes 3 arguments. The first is a string, which is appended to the URL of the API. The second is the view function that we just created. Ensure that this says listCreateWord and not listCreateWords. You may need to make a change in your view class. When using class-based views, you have to call the asView function as to return a callable view that takes a request and returns a response. The name argument describes the path and is optional. Sometimes you may want to name views so that you can refer to them rather than by the URL. If the URL changes in your app, you only need to update the code in one place. Open the terminal and run the server using Python manage.py run server. If you can't remember the name of the URL to open the API, you can take a look at your URL patterns in both url.py files. Since I added v1 to the urls.py in the app folder, I'm going to remove v1 from here. If you go to API/v1/words, you should be able to see all the words in the database. The HTML form is only visible if you have logged into the site as a super user. I'm going to post a word to the database using the HTML form, which in my opinion is easier than using the Django admin console. We also have the option of adding data in a raw format by clicking on raw data, but that would have to be entered as a JSON string. Return to the IDE and let's add a class that will allow us to delete and update items to the API. Create a class named retrieveUpdateDestroyWord, which is going to inherit from generics.retrieveUpdateDestroy API view. Copy the query set and serializer class attributes from the listCreateWord class. Open urls.py in the app folder. We need to add a path that will take us to a single item. Type v1/words/ and place int::pk in angled brackets as a string. At this point, you should notice that we have repeated v1/words in our string. How would you fix this? For the next argument, type the name of the classed baseView function and be sure to use the asView function as well. For the name, type word detail. Remember that this is a list and these path items should be separated with a comma. Run the server again. If we append 1 to the URL, this will take us to the item that has a primary key of 1. We now have the option to delete this item, and we can do so by clicking the delete button. If we go to v1/words, we can now see that the item has been deleted. If we append 3 to the URL, this will take us to the word codetermination. In the example, I'm going to replace Germany with Barbados and hit put when finished. If we go to v1/words, we can see that the item has been updated. In order to get better at programming, it is good to challenge yourself. I want you to refactor the URL pattern string in the path method in the app's url.py file. Then I want you to push the changes to a new branch on GitHub. Pause the video if you need more time. In the first and second URL patterns, we have v1/words. We can move this from here and append it to the URL pattern in the project urls.py file. Copy v1/words and append it to the string in the second URL pattern in the project urls.py file. We can now remove v1/words from both URL patterns. Run the server to see if the API is functioning as expected. We can now push these changes to a new branch on GitHub. Type git checkout -b followed by a name for the branch you want to create and hit enter. Type git add period and hit enter. Add a commit message and hit enter. Finally, we want to push this branch to GitHub. Our new branch is now visible on GitHub. In this section, we're going to define a viewset, discuss the model viewset class, and use a viewset with our API. Viewsets combine the logic for a set of related views in a single class. It is a class-based view that doesn't provide method handlers such as get or post, but it provides actions such as list and create. You need to register the viewset with a router class, which automatically determines the URL configuration for you. The model viewset class inherits from generic APIView by mixing the behavior of the various mixing classes. You need to provide the queryset and serializer class attributes. The actions provided by the model viewset class are .list, .retrieve, .create, .update, .partial update, and .destroy. We are going to create a separate file for the viewset class, similar to what we did in the previous sections. We will name this file viewsets.py. From the REST framework, we are going to import viewsets. Then we need to import the models module from the current folder, as well as the serializers module. Create a class named wordViewset, which will inherit from viewsets.modelViewset. Just as before, we only need to provide a queryset and a serializer class, and that's it. We are finished with our class-based view in 3 lines of code. Open the app.urls.py and let's first comment out the code that we don't need. Import routers from the REST framework. Import the viewset module from the current folder. Create an instance of default router and store it in a variable named router. The register method requires 2 mandatory arguments: the URL prefix to be used for this set of routes and the viewset class that we just created. Call this method on the router object. Finally, we just need to append the router URLs to the URL patterns, which at this point is an empty list. It is also possible that this code could have been written in the project urls.py file. The router is responsible for generating the different routes that are available for our viewset. Run the server by typing python manage.py run server and hit enter. Using a default router gives us a basic route view. Clicking on this link will take us to our API. We have 2 words in our word list. There's a count attribute, next, and previous. The count lets you know how many items are in the database. The next will take you to the next page, and previous will take you to the previous page. If we append 2 to the URL, we will go to the item that has a primary key of 2 in the database. When we are here, we can delete or update this entry. Return to the editor and open settings.py and change the page size to 1. What do you think will happen? Return to the browser and refresh the page. The count has remained the same, but now we have the option to go to a next page without having to append the primary key value to the URL. We also get this neat little menu in the upper right-hand corner under Options and Get, which allows us to browse the API. In this video, we're going to define a mixin and show how mixins can be used to customize behavior. Mixins are smaller classes that can be combined to make a bigger class. If you wanted to create a base viewset class that provides create, list, and retrieve operations only, you need to inherit from generic viewset and mix in the required actions. Create a new file named mixins.py in the app folder. To make life easier, we can copy the code from viewsets.py. Paste the copied code in mixins.py. Import mixins from the REST framework. To customize the behavior of our class, we need to change the classes that we inherit from. The model viewset class is made up of many smaller classes, and we will choose the ones that we need. To create items, we need to inherit from mixins.create model mixin. To list items, we need to inherit from mixins.list model mixin. To update items, we need to inherit from mixins.update model mixin. Finally, we need to inherit from viewset.generic viewset. Open urls.py in the app folder, and you can choose to comment these lines or delete them. We don't need them anymore because we are using mixins.py. We need to register the router just as before. This takes two arguments, a string and our viewset. We need to import mixins from the current folder. Open the terminal and run the server. We should be able to create, list, and update items in the database, but we don't have the ability to delete items. We have a minor problem here because we don't have the ability to retrieve items. If we can't retrieve, we can't update. Let's add that functionality through the editor. In mixins.py, let's add mixins.retrieve model mixin to the viewset class. This will allow us to retrieve items from the database so that we can update them. Refreshing the page allows us to see item details. The delete button is missing from the upper right-hand corner because we haven't added that functionality. We can add it by adding mixins.destroy model viewset to the viewset class. If we refresh the page, we now have the option to delete items from the database. Now that you have completed your app, you're going to want to write tests for it to see if it performs as it should. We could have built this app differently where we wrote tests before creating the actual app. This is called test-driven development, but that may be a little intimidating to people who are new to the Django Rest Framework. If you would like to learn how to write tests for Python code, please subscribe to this channel. Once you are confident that your code works the way you want, you can deploy the API using Heroku. I plan to create a course on Heroku sometime in the near future. If you are already subscribed, you can turn on the bell icon to be notified when the course has been made available. Thank you for watching.